Hi, welcome to our pre-calculus. Topic today is very similar to what we had in the last lecture. The only difference is that we are limiting our answers to be in the interval from 0 to 2 pi, or the so-called first circle. So we are going to be quick in this thing because most of the work was already done. So the first step, call this thing by some other variable, say theta. We look here, this one is in x, so we just choose another letter. Anything would do. 2x, so I have 2 sine of theta plus 1 equal to 0. So that tells me sine of theta is equal to minus 1. We draw a unit circle. We remember this is the sine axis. On that sine axis, we find minus 1/2. Minus 1/2 will be here. We connect this thing to the origin, and then we get these two angles. We can go any direction. Here the substantial restriction is that the final answer has to be between 0 and 2 pi. So let's go ahead and perhaps label them originally to be in that range. So I have one answer, which is okay, so this is pi plus pi 6, so this is 7 pi 6, and the other answer that I have is 11 pi 6. That's the second one that comes all the way here. Now the question is that 2x is to be equal to these quantities, and I can have 7 pi 6 plus 2k pi, and the other one is, 11 pi 6 11 pi 6 plus 2k pi. So these are the values of theta. That one now we are not caring about what angle you want to be. So x is connected to theta by being x is connected to theta by being half of theta. So x is theta over 2, or 2x is equal to these quantities. So x becomes 7 pi over 12 plus half of that is k pi, and this one is going to be 11 pi over 12, and half of that would be k pi. Now the main question is for what k's, for what values of k is x in interval from 0 to 2 pi. So really we have to solve an inequality there to get the answer, but let's just do trial and error now. If k is equal to 0, obviously I have an answer. So x 7 pi over 12 is already fine. And then now the question is, can I add some multiply pi to it? For example, can I add a pi to this? Well, so if I have 7 pi over 12 and add a pi to this, do I exceed 2 pi? No. This is less than a pi, plus that one makes an angle that is between 0 and 2 pi. And therefore I just add them. So you take a common denominator, 12, 7 pi plus 12 pi. So that becomes 19 pi over 12. So next possibility is 19 pi over 12. Well, can I add k equal to 2? Well, no. Obviously I'll be above 2 pi. So if I put 2 pi here and add something to it, obviously I will be more than 2 pi. So that is out. Can I take k to be minus 1? If I put minus 1 here and add to that, you get a negative angle, and I'm going to stick out of the other end of this thing. So that's not good either. Next, 11 pi over 12. And again, I can add 1 pi to this, 11 pi over 12 plus a pi. Let's see. So if I have 11 pi over 12 and then add a pi to this, I get what? I get 23 pi over 12, and that's still short of 2 pi, and I'm all done. So we have 4 possibilities in 0 to 2 pi, and so the main issue here is to choose what multiples of pi can you add and still be inside the first circle. How about here? So I take a theta to be x over 2. So now I have 2 cosine of theta plus radical 2 is equal to 0, which tells me cosine of theta is equal to minus radical 2 over 2. How do we handle the angle itself? Either look in the table or draw the unit circle. You remember this is cosine. Minus radical 2 over 2 is here, more or less. And your angles will be this one, which is theta is 3 pi over 4. Or this one comes all the way here. So that is 5 pi over 4. Both of them give you cosine of minus radical 2 over 2. As before, we can add a multiple of 2 pi to this. So these are all the solutions. However, this is x over 2. It's x over 2 that is equal to this angle, and or is equal to this angle, 5 pi over 4 plus 2k pi. So what is x? Well, I have to multiply both sides by a 2. So it becomes 3 pi over 2 plus 4k pi, and this becomes 5 pi over 2 plus 4k pi. So far is all just like we did in the previous lecture. Now the next question is, what case can I use? I cannot leave the problem like this. I have to choose my case so that I'm in the appropriate range. Well, of course, if you choose anything other than 0, you get out of the range. If k is equal to 1, it's already 4 pi, and let's see, what did I write here? Let me correct my writing here. It's strange. 3 pi over 2. So 3 pi over 2 by itself is fine. I can neither add 4 pi to it nor subtract 4 pi from it and get something in the acceptable range. So that's all stays here. Same way here, 5 pi over 2, that is okay. That is, well, excuse me, 5 pi over 2 is already exceeding 2 pi again, so this is also out. You subtract 4 pi from it, it becomes negative, and that one is also out. So the only answer that survived all of this screening process was 3 pi over 2. So 3 pi over 2 is our final answer. Next in this type of questions is this one. I just included it so for 2 reasons. One is the coefficient is not a whole number. Second thing is that the letter theta is used here. So if you want to use substitution, just use some other letter. Whatever you use, that's fine. So I say W. W, I call it to be 2 theta over 3. That's fine. So my equation now reads cosine of W plus 1 is equal to 0. So cosine of W is equal to minus 1. Cosine of W equal to minus 1 means we are right at this corner, which W has to be pi. To that, I can add any multiple of 2k pi. So I can go around an odd multiple of a pi and I'll be all okay. Now I say my W is 2 theta over 3. That is what is pi plus 2k pi. So theta, I multiply by 3, divide by 2, so 3 pi over 2 plus 3k pi. So multiply by 3, divide by 2, and that's what you get. Now we try. If take k equal to 0, I get an angle, which is fine because I am in the appropriate range. If I k equal to 1, what do I do? 3 pi over 2, and then you add 3 pi to it. Then theta exceeds 2 pi. So that is not acceptable because we are getting out. What if I take k equal to minus 1? Well, now I'm subtracting 3 pi from this. 3 pi over 2 minus 3 pi is going to be minus 3 pi over 2, and that one is also out. So the only solution that survives this screening process is the value of 3 pi over 2, and then we are all done. So questions identical to previous time. The only complication is choose your case so that you stay inside the given range of values. That was the main challenge of this problem. Okay, so you try several of these and you'll be good to go. Until next time, good luck and God bless.